Sir, now we are on live.
Okay. Good evening, everyone, and welcome to this very exciting event organized as part of the Cosmic Zoom exhibition. I hope many of you know this already. Cosmic Zoom is a virtual exhibition that was curated by several scientists and artists at ICTS. And it offers a trip over the different length scales in the universe, starting from the smallest subatomic particles and going all the way up to the full observable universe. And you would see some very, very interesting connections between phenomena happening at these very different scales also. So the website of the Cosmic Zoom is advertised here. It's www.cosmic-zoom.in. We are also organizing several events as part of the launching of this exhibition. And you can check them out at cosmiczoom.in/events or on the Cosmic Zoom Facebook page and other social media. And today we are particularly excited to present this very interesting event, a day in the lab with the Indian Astronomical Observatory located in Hanle, Ladakh. Most of you must know that Hanle is one of the remotest and the highest and driest places in the whole Earth. It's an ideal place to do astronomy. So the Indian Institute of Astrophysics has set up an astronomical facility at Hanle, which operates several telescopes. And today we have two scientific and technical staff members from the Indian Institute of Astrophysics introducing us this observatory. And this is going to be a very exciting session. So I'm very glad to introduce Dr. Ramya Sethuram and Mr. Dorje Angchuk, who would be leading us to this very exciting session. Ramya is an astronomer who is based at the IIA, Indian Institute of Astrophysics, Bengaluru. She's a project scientist at the All India TMT Center at the IIA, Bengaluru. Her research interests are in star formation processes in dwarf galaxies and stellar population and star formation histories of low luminosity galaxies. And she also has a huge amount of interest in the astronomical observation and outreach as well. And Dorje Angchuk is an engineer in charge at the Indian Astronomical Observatory in Hanle, and is among the key staff members involved in the commissioning and the operation of the telescopes at the observatory. Apart from this, his immense professional contribution, most of you know that he's an outstanding photographer. In particular, his astrophotographs have been featured in leading publications across the world, such as New Yorker magazine. So today we'll start with a short presentation by Ramya, which introduces the observatory as well as the telescopes in that observatory. And at around 6:30, we'll take a few questions after Ramya's talk, very, very quick questions only. And about 6:30, we will switch over to Hanle with a live video session, and where Dorje and his colleagues will take us through the observatory, and showing some really exciting things happening at this remote part of the world. So I encourage you to put on. So for those of you who are on Zoom, I encourage you to put on the gallery view, because if you put on the standard speaker view, you will probably miss out this very interesting and exciting live video session from Hanle. And both Dorje as well as his colleagues Tansing will show different video feeds from the site. So I encourage you to put on the gallery view from Zoom. So with this introduction, let me invite Dr. Ramya Sethuram to give her introductory presentation. Ramya, please.
Thank you, Ajit, for a very kind introduction. Let me share my screen. Can you see my screen?
Yes, madam. Can you
okay.
Screen? Yeah, yes.
Is that okay now?
Yes, ma'am.
Yeah.
Thank you.
Hello, everyone. Thank you for joining today. Today, I wish to thank ICTS and Cosmic Zoom team for bringing us together, the astronomers and the public who are interested to know what is happening in the Astronomical Observatory. Today, I will say a few words about Indian Astronomical Observatory and the 2-meter Himalayan Chandra Telescope. Where is it situated? And what happens during an observation. I gave a very brief account. After that, we will see the life going over to the Hanle. So, astronomers need dark sky for observations. And why is it so? Because what do astronomers do? Astronomers study celestial objects through the light emitted by them. So we just collect the light from these celestial objects and we observe them. So we will require light being collected in all the electromagnetic spectrum, starting from radio to gamma rays. So, and for this to happen, because the objects are so far away, millions and billions of light years away, we want, these are fainter objects, and hence we need minimum man-made interference in these observations. So for that, naturally, you will go to a remote site. You also need to go to a high altitude site because, as we all know, turbulence is a problem which is created by the atmosphere. Of course, we respect the atmosphere, without which we cannot be here. But for astronomical observations, this is going to create a problem. So what I show here is how the light from different wave bands is being affected by the presence of atmosphere. So as you can see, we can see the optical light, or what we call the visible light. It passes all the way through the atmosphere and reaches the sea level. But when it comes to UV, X-rays, and gamma rays, we are completely missing out. Similarly, is the case on either side. On the other side, the infrared and the microwave, though we can get a little bit of microwave. So we have to go slightly above the so that slightly above in altitude, so that we cut off at least 50% of the atmosphere. And that can happen if we go higher in the atmosphere, higher in the altitude. So atmospheric turbulence decreases with altitude, that we saw, and scattered light also decreases with altitude, making the sky fainter. High altitude is the next best to space platform, and it is also a lot more cheaper. That's why astronomers need a dark sky. This is another view of how the night sky pollution also affects astronomers. So we generally don't want to have our observatories within the city, because all these bright points are coming from metropolitan cities. So we would like to go to a remote site where the emission from humans is the minimum. So this is another view of the light emission from the humans, and on top of India, basically. And you can see a faint region over here, which is almost devoid of human emission. And that is the Trans-Himalayan regions. Otherwise, rest all of India is lit, and it is not a good site for astronomical observations. So we have to go to high altitude sites and remote sites. High altitude sites in the world are, for example, we know there is a lot of observatories at Mauna Kea, Hawaii. Then there is a set of observatories at Atacama Desert. And we have our Trans-Himalayan Plateau, where we have our Indian Astronomical Observatory. Also, just on the other side of the border, there is the China's new Ali Observatory, which is very similar to our Indian Astronomical Observatory, but slightly higher in altitude, about 5,100 meters. So, but they are still in a very developing state when compared to the Indian Astronomical Observatory at Hanle. So these are the telescopes in Hawaii. You can see the traffic is quite huge here, and also the traffic is getting a lot of traffic in La Parnal as well. Another important thing is that if you see on the longitude way, we don't have much of the telescopes in this particular longitude zone when compared to this longitude zone. So it's better to have and maintain this very good site, what we have found out. So where is this Indian Astronomical Observatory? If you see, this is a slightly older map. I couldn't get the newer map. This is Leh Ladakh, and about 250 kilometers down, close to the border, is Hanle. And if you, this is another image. So if you, this is how the satellite image looks of Leh and Hanle. So now, if you have to reach the Indian Astronomical Observatory from Leh, there are actually, if you can see, there are actually two roads. One road goes via Matho, Upsi, and Nyoma, Rongo, and then reaches Indian Astronomical Observatory. The other road is a bit interesting, where it passes through Merrick, which is where the National Large Solar Telescope is going to come up, next to the banks of Pangong River or lake, and then you have to cross Chulchul, and again via Rongo you can reach the Indian Astronomical Observatory. So this is the another satellite view, and this particular site is at 4,500 meters above mean sea level, and this is the observatory is located on Mount Saraswati in the Western Himalayas in the Hanle Valley. It's a dry, cold desert. Absolutely no human population. There is a Hanle monastery, Gompa monastery, which is the most nearest neighbor and many kilometers away. So the rainfall is very minimum, less than 70 millimeter. We don't want clouds to block our observations. So it's a dry, cold desert. When you compare it to the Thar Desert gets more rain, 100 to 200 millimeter in a year when compared to Hanle itself. So this is absolutely cold deserts. This is how the site looks from the base camp, and you can see how beautiful the blue sky is. This is what we expect, and we get about 260 spectroscopic nights, that is nights with thin clouds, and 190 photometric nights, that is absolutely clear nights of 190 nights per year. So I'm just going to flash. I have said that Hanle is one of the best sites, and you can see how many stars you can just see during the night sky. This is all images taken by our colleagues on the Hanle site. This was the comet Neowise, a very famous image by Dorje. And this is the 2-meter Himalayan Chandra Telescope. You can see we will see in live this telescope. Basically, this 2-meter Himalayan Chandra Telescope has a 2-meter primary mirror. That is the size of the primary mirror here. And it has a secondary mirror, and the light from the primary mirror gets focused onto the secondary mirror. From there, the light is again directed into the instruments below the primary mirror. So the light from the celestial objects is parallel. It gets reflected onto secondary. From secondary, it enters into the, it is directed into the instrument. So what are the instruments, science instruments? So we have HFOST, which takes images and also spectra. We have in the optical region, we have IR, which is which takes IR images and also spectroscopy. And we have a high resolution spectrograph where you can really take very high resolving spectra, high resolution spectra. So how do we observe with 2-meter HCT? Though the conditions are great for putting up a telescope, it's not so good condition for everybody to go and observe there. So what we have is a dedicated satellite link INSAT 3B, which is giving us a bandwidth of 63 megahertz bandwidth, and it's a point-to-point link. So so a person sitting at Hosakote in the CREST campus, which is also another campus of IIA, can remotely observe the 2-meter Himalayan Chandra Telescope. So a person sitting here, all the astronomers are directed to go to CREST campus and do their observations with the 2-meter Himalayan Chandra Telescope every night. So a person sitting here will send commands. The commands will reach INSAT 3B and to Hanle via the dedicated link. So that's the way we take the observations. So these are some of the beautiful images from HCT. So all kinds of observations are happening, star-forming galaxies to low surface brightness galaxies to dwarf galaxies to Eagle Nebula and Crab Nebula. All kinds of observations have been happening. So when you want to observe with a 2-meter telescope, you need to have something called as a RA deck. This is nothing but the latitude, longitude projected onto the celestial sphere. So how we locate places on Earth using a latitude, longitude, like that you have to locate your source on the celestial sphere using an RA deck. So there are several catalogs available to detect your, or to observe, or to get RA deck of your favorite galaxy. Once you get that, you have to point the telescope to that direction using the RA deck coordinates, then start guiding. Then you have to take calibration frames. Once you are done with the initial acquisition, then you can start your observations of the target. So these are some of the very raw frames and raw spectra which we have taken of the very faint object here. It's a GRB. So that is the spectrum. So what is next with HCT? We have said that we have the capability of putting up a 2-meter telescope at a 4,500 meter mean sea level. Next is to aim higher, because we want to understand using a larger 10-meter class telescope, that is the primary mirror size is going to be 10 meter in comparison to the 2-meter. We have to understand whether some of the questions we want to ask and answer is that, are we alone in the universe, like exoplanet search, and atmospheres, to find out atmospheres of these exoplanets, whether does that make it a habitable planet or not. So the next project, the National Large Optical IR Telescope, will come very close to HCT, and it is still in the concept phase. So that's where I end here. I thank you, and I say over to Hanle.
Thank you very much, Ramya. Would you like to take a couple of questions before Dorje starts? So I think there was a question on whether the telescope site is affected by cosmic rays, seismic activity, and high energy gamma rays, etc., because you are so high up.
First, let me take first cosmic rays. Cosmic rays are there everywhere. So you have to plan your observations that it won't affect your frames very badly. As I show you here, many of the dots here, something like these could be cosmic hits. So they have a different profile when compared to a star profile. So that's how we can remove. There will be cosmic hits, and we can easily remove when compared to the star profile. These will be like a delta function, and the star profile will be more like a Gaussian function. So we can remove them. And the second thing is gamma ray. No, this we will not be affected, because the CCDs are kind of only looking at the optical. So, but it is definitely a good site for gamma ray observatory. I didn't go into the details of it. There are two observatories. One is called the Hagar, and the other is MAZE, set up by TIFR. So these two are Cherenkov. They have Cherenkov detectors. So they detect gamma rays of objects like blazars and very high energy black holes, black hole sources. So it is not going to affect the optical observations. And what was the third thing? Seismic activity is very low at this site. That is being measured. Hello? Hello? Did I lost you?
No, madam.
Oh, sorry, Ramya, I was speaking to a muted mic. Yeah, thank you very much for this answer. So there is another question on the telescope that China is planning to put at across the border. So is the ALI telescope also in optical IR bands, or is it a microwave observatory?
Yeah. So not much known about the Ali site. Ali site is just they are monitoring the Ali site since past 10 years. So it is at 5,100 meters, and it's not a very it's mostly a hostile condition for any human to work over there. So they are still thinking. They are also planning for a 12-meter class telescope, and they have an alternative site close to Russia as well. So I don't know what will they choose, but they are using the early site for checking the sky. From past 10 years, it is coming up. So it is still very nascent when compared to IAO.
Okay, thank you, Ramya. There are also a couple of questions on how we can get the data or images from the observatory, etc. Can we request specific images, for example, an image of supernovae, etc.?
Yeah, so the observing policy is that you have to send a proposal. You have to send a proposal. There is a proposal committee or the time allocation committee which checks the proposals and allots time. So the proposal for this particular telescope is open on three times in a year, and it's available in the website link which I gave. So one can put the proposal and and get observing time for observations.
Okay. There is a question whether the HCT use adaptive optics yet.
No, not yet. So HCT does not use adaptive optics, while the next generation NLOT, National Large Optical IR Telescope, will definitely use AVO capability.
Okay. There is also a question, how do you model the PSF of the detector? It's written PSD, but I think the questioner meant PSF for the detector.
Yeah, so during the testing, you can observe a bright object, and also you can observe a bright object, get its profile, measure the profile. That is one way. There are multiple ways to do this. So that is what is called the commissioning tide, where you try to observe various bright objects, especially stars, to model the PSF of your system and to correct for your image quality to make it more better. So generally, as an observer, you will use stars profile to find out the PSF, point spread function.
Yeah, thank you very much, Ramya. There are many more questions, but I suggest that we go to the Hanle Live now, and we can come back after that because we have to close the Hanle Live session at 7 o'clock and hand it over to the real astronomers. So we have now Stanson showing the video from the observatory, the outside of the observatory. So if you are not seeing the video, you can actually watch it. You look at the gallery view and click on that video, and it's an exquisite sky that you can see there already. Dorje, are you there? Stanson, if you want to say something here to describe what we are showing, what we are seeing, please go ahead.
The HCT just have opened the dome. You can see there that smaller one is a 0.7 meter for a growth telescope. The smaller dome you can see there, right?
Yes, we can see that. Yes, thank you.
Okay, so it's a bit windy. I'm not sure whether you are hearing me or not.
We can hear you very well. There is a bit of noise, but we can hear you. Please go ahead, Stanson.
Okay. Okay, so okay, so they're calling me up there. So I will show a closer view from outside. It's visible there. You can see. And let me show you how it looks from here. That's Hanle Monastery there, and it's a clear sky. It was very cloudy in the daytime, and right now it just got good clear
So we have entered the observatory, as you can see.
Oh. So we have to climb almost this much of stairs to the telescope. Okay. Okay. So I'm muting myself now. Over to Dorje Angchuk, sir.
Stanson, what was the temperature outside?
Okay, so I've just reached the top and Angchuk sir will further. Okay.
Dorje, please unmute your mic. Please.
Am I audible?
Yes, yes, yes.
Okay. I'm sorry, I had an issue with my mobile, which we thought we will showcase everybody. This Himalayan Chandra Telescope. My name is Dorje Angchuk, and I'm working here as an engineer since last 20 years. So I was here since the building of the telescope. So as you have seen through Sanjay's video and the fantastic talk that Ramya gave just now about this telescope, about the capabilities of this telescope, I will now show you the preparation going on before we actually go to the observation. As you can now see, the telescope is moving. This telescope is actually as small azimuth cross telescope, that is, it can rotate 360-degree in azimuth and 90-degree in altitude, and it can cover the whole sky. So here we have this telescope. This telescope is actually a 2-meter class telescope. This classification is based on the primary meter dia, which is 2 meter. So right now we will show the opening of the mirror cover. Right now, just because it has become dark, so here you can see mirror cover is getting opened and the dome is open. So here right now the mirror cover is getting opened and the mirror will be exposed to the sky for further astronomical observations. So this is the in the center of the image is the 2-meter class, that is 2-meter mirror, primary mirror. So the light sources coming from far away comes as a pattern place, and it reflects the primary mirror, which is a hyperbolic, and it is reflected. This is the secondary mirror on the top. It is getting reflected to the secondary mirror, and further it is reflected back to the tertiary mirror, which is also called the instrument cube. I will show you around. This is called the operating floor of the telescope. This is the instrument cube that we have here. So basically, this instrument cube, it can house 4 instruments at a time, which I will describe you. So this the first one, which is our main instrument. This is the HFOS. This is called the Hanle Faint Object Spectrograph Camera. This one basically we can do both imaging as well as spectroscopy in the HFOS.
So I think it's a bandwidth issue again.
Yeah, did we lose Dorje? Dorje, I think we have lost you. So maybe Ramya, you could use this time to answer some more questions. Are you okay with that?
Sure, sure.
Okay, so one is what are the kind of projects that are going on right now? What kind of objects are astronomers observing these days?
The major so there are stellar group, the stars group, and the extragalactic, that is galaxies, not our own, but galaxies apart from the Milky Way. So these two are the main kinds of observations happening. So people observe transients also, like supernova, nova, and gamma ray bursts. So all these things will be observed using the HCT. Also in the stellar, people are observing like giants and very bright stars can be observed using the 2 meter HCT. And using the galaxies, as I mentioned, a lot of dwarf galaxies, a lot of star-forming galaxies can be observed, like to study what kind of star formation is happening in these galaxies. So all these programs are ongoing with the HCT.
Okay, thank you,
I
Ramya.
think they are back.
Yes,
Yeah.
yeah, it looks like Hanle is
we are back. Sorry.
Yeah, please no,
There
go
was a
ahead. Please,
connection.
yes, please go ahead, Dorje. Yes.
Basically, as I was, we are very sorry for the network connection, so we can estimate how remote we are situated. So this is the H-force camera. It has got a narrowband filter which are centered around spectral line to study the emission like H alpha, S beta, sulfur, etc. And the H-force can also do spectroscopy with a combination of prism and slits. So the optical wavelength of this H-force is around 3,500 angstrom to 9,500 angstrom. So then you can, our second instrument is the, I can show you, this is below here. This is the HES, which is the high resolution Escher spectrograph. So basically in H-force we have got the resolution of 3,500, which means that we can especially separate by 3 to 4 angstrom. While as in has we have got two modes of resolution which are like 30,000 and 60,000. So in case of 30,000 we can resolve the spectral lines by 0.2 arc second, while as in 60,000 mode we can resolve the spectral lines to 0.1 angstrom. And so this are used to for detailed study of the chemical composition of the astronomical sources. And our third instrument is called the TISPEC, which is the Tata Institute of Fundamental Research
Guess we lost them once again, and hopefully they will come back.
Infrared camera to study the stars, basically, which are actually the young stars which are embedded in the molecular cloud, in which they were formed. Actually, so basically, what happens? Those the starlight coming from this gets embedded in the molecular dust and gases cloud, and hence we can resolve that in infrared camera rather than an optical camera like H-force and SS. So that is why infrared camera is used here, and I think this is the only location in India where we can do infrared spectroscopy and imaging. And the wavelength range for infrared camera is like from 1 micron, 1.1 micron to 2.5 micron, so you can cover NIR range very well. So this is the and we have got another instrument which is the fourth one. Basically, that is an Shah-Khanwan camera. This is the yellow one that you can see here. Basically, it is used to actually characterize and fine-tune the primary mirror and the secondary mirror. Basically, as you can see right now, the flat imaging is going on, and hence the telescope has aligned with the dome slit wherever it is positioned. So it can rotate 360 degrees wherever the objects are, and the dome also follows the telescope. So here you can see some outside view from inside the dome. This is here right now, it's becoming dark, and then this is the Hanle plains. And basically you can, I will show you the dome. Basically, this dome is a rail arrangement, which is actually run by 4 motors, 1 HP each, like I'm showing here, on each north, east, west direction. So here it is a completely opposite of what the train is. Rail is the track is above, whereas it is driven from down. The other things are guide wheels and drive wheels and guide wheels. So this complete more or less the things happening here now. The telescope operator in the control room, he's operating the telescope and getting the flat wheels and preparing the telescope before the observer at Hosakote takes it over. Thank you very much.
Thank you very much, Dorje, for this exciting tour of the observatory. So can I ask a couple of questions? One is, so the observers directly operate the telescope from Bangalore site, or do they have to pass instructions to an on-site operator?
No, yeah, the observers, they can take complete control of the telescope, operate the telescope, and then we don't have to be here throughout the night. The observer can do all the things. Move the dome, move the telescope, take images, save the images. So, but they don't transfer the images at the same time because of the bandwidth issue. As you have seen just now, we got disconnected. The data transfer happens during the day when there is no operation of the satellite link that we have here.
I see. Okay. And by the way, people on Zoom or on YouTube, this would be a good time to ask any questions to Dorje Angchuk and his colleagues on site, and I can read the questions for you. And meanwhile, I can ask one more question. So, who built the telescope and the mechanical setup?
Yeah, this basically this was our first test run for putting up a telescope at a remote site, which is equally quite remote from even Leh. So this telescope was having a very short season. We cannot. We have to complete this project and showcase that we can actually operate a telescope in such a condition and such a remote place. So that we ordered the telescope from a company called EOS US Electro-Optic System, America, and the dome was fabricated in Jammu by a company called Mangi Engineering.
I see. Okay, thank you, Ajay. There are lots of questions coming. First, a lot of appreciation of your photography work. Many fans. One question is, what is the temperature there?
Okay, the temperature actually, the minimum it goes to minus 5-7 nowadays, and the minimum I've seen is like minus 27 here.
Minus 27. And what is it now?
Right now it must be like around minus 1-2 degrees.
Okay. Okay, great. There is a question from Bertie. He is asking Dorje, what is the most?
It is the wind chill factor which is more colder and terrible here. So we have to stay protected ourselves all the time, because just we are on a hillock, and you know, on a hillock the wind flow is more.
Yeah, it must feel much colder and drier.
Yes.
Yes. Okay. So Bertie is asking Dorje, what is the most interesting thing that you have seen from Hanle?
Most interesting
thing that you have seen from Hanle?
Oh, I see it every summer. It is the Milky Way. You should actually come here. Anybody should come here and actually see the Milky Way with their own neckties. You don't need any instrument. You don't need camera for that. Particularly on a dark night. By dark night I mean moonless night, and it is fantastic, superb. You will realize the beauty of our skies here.
Yeah, you might actually have trouble with too many tourists now, because a lot of people are asking, how can we visit the Hanle site?
Okay, the Hanle site, actually it is around 270 kilometers from Leh. At Leh, you will have to, if you are coming by air, you have to be acclimatized well, and for next 2 days, and then you can travel 270 kilometers, which takes around 6 to 7 hours. And then there are quite a lot homestays in Hanle nowadays. And uh, also you need the permission from the district administration. Right now, it is restricted only for daytime for certain reason unknown to us. But then definitely till last year, it was like everybody can visit Hanle, no matter what, with the permission.
Okay, thank you, Dorje. There are a couple of curious students are asking the question, are there any internship programs for undergraduates or graduate students at the IAO?
No, right now we don't have, because of the conditions here and the remote site that we are having here. Maybe we will have to think about it later on, but not right now. We don't have such programs.
Okay. So there is a request for showing some images taken by the telescope, and I think Ramya has already shown something, and she hopefully can show us some more images after your live session. Next is a comment.
I think I saw in Ramya's slide there were quite a lot of images, so that can be viewed.
Yeah.
And basically, this is an telescope which is used for fundamental research, and not many pretty images are generated from this telescope, contrary, which is quite an setback or for many people. But this is highly used for scientific research and not for whatever NASA Hubble kind of images that we get here.
So next is also another common question. What is the range of the telescope? How far can you see?
Oh, I think Ramya can answer it more well, but I've seen many images which are like millions of light years away. And it all also depends on, to put it very simply, it also depends on how much you can open the shutter of the CCD camera. The longer you open the shutter of the CCD through the auto guiding that we have, we can go deeper into the sky. So as such, there is no magnification in a telescope, but it depends on the longer exposure that you give.
Yeah. Another interesting question is, how do you keep your mirrors clean? Do you have to occasionally polish it again?
That's a very nice question. We are actually blessed with very dry atmosphere here, and only during daytime or nighttime, only certain dust they fly and settle on the mirror, and we keep the mirror cover closed, as you have seen the opening also, and there is a shroud also which actually protects the mirror, and we also have an annual maintenance for 1 month period, 15 days in summer, where we clean the mirror with distilled water.
Just distilled water. There is nothing, liquid nitrogen, nothing like that.
I'm sorry, can you repeat the question?
Just distilled water, nothing more.
Okay. Yeah.
There is also a question on, can you please tell us about the telescope maintenance? How do you care for such a large mirror? What are the challenges in Hanle?
Oh yeah, basically we are like we have a certain period, like every month we have like 5 days maintenance period where we take care, we check all the instruments, and we do all the housekeeping of the instruments, and also there is a 15 days annual maintenance. We thoroughly check all the instruments and all the motors, anything running on all the signals in the encoders, amplifiers, and that did the job for the last 20 years, and it worked very well. And if there's any outrage, we solve it our own.
By the way, how old is this telescope? How old is
yeah, we just celebrated 20 years of HCT last year.
I see. So there are a few more questions.
Years.
Okay, great. Yeah, yes. There are some more questions. Are there any formation of water crystals due to low temperature and other deposits because of the mirror smoothness will be around a few nanometer? I guess you have answered it already. It's a very dry place, right?
Can you repeat, Ajit? Are there
any deposits of water crystals because of the low temperature?
Basically, yeah. When Hanle was chosen, it was chosen such that it is in a rain cloud shadow area beyond the Himalayas. And we are unaffected by both the monsoon, that is the western disturbance, and the southeast monsoon, as everything gets precipitated either in the Himalayas, Uttarakhand, Himachal, and western disturbance, everything happens in Srinagar, Kargil, Dras area. So this is a very rain shadow area. So we have hardly any rain, and whatever we have is a very dry flakes, and so we don't have any mist problem, no ice crystal forming, even though the temperature goes very low.
So where do you get water? Is it from the snow only?
We have dug some borewell. Basically, Hanle was 150 years back. Hanle was the biggest freshwater lake, which has now dried up. So there are plenty of glacier water melting, and so if we dig it around like 250, 300 feet, we can get easily water, that too in the base camp, and so we supply it from our lower where we stay to this telescope.
I see. How about electricity? Where does it come from?
Oh yeah, that is the most one of the brightest future of this observatory. We are operating on a solar power for the last 20 years, and never in this 20 years we switched on the DG for operating this telescope.
Okay, yes, great. There are some questions about the camera.
It's a green telescope.
Yeah, it's a completely green telescope. Yes. Yeah, there are some questions about the camera. What kind of a camera is that?
Yeah, basically we have CCD cameras here, which are cooled with the help of liquid nitrogen, and they are maintained at 180, 90 degrees. All the three CCD cameras are maintained at minus 180, minus 120 degrees Celsius.
Okay, thank you, Dorje. There are some more technical questions. What is the type of a mount of the telescope?
Oh, this is an alt azimuth mount. Altitude was azimuth mount, which I initially told. So it can rotate 360 degree in azimuth and 90 degree in altitude.
Okay, and what is the resolution of the camera? What is the megapixel?
It's for right now for at first we have like 2K by 4K camera.
Yeah, it's on the face it doesn't look any much improved.
So here the pixel size are big, and we could gather more photons. So they are not like whatever we get in the our mobile or DSLR camera 40 megapixel. So here the pixel size are very big.
Yeah.
So it's only 2K by 4K, 4K by 4K.
And they are extremely low noise detectors, right? So because in astronomical observations, you're only encountering a few photons, which is that's why you have to go this very precise cold cameras detector. So there is some question: are you an astronomer or an engineer?
I'm an engineer. Basically engineer and a little bit of amateur astrophotographer. So just my work and hobby is intermingled here at Hanle.
Yeah, I guess many people would be curious about this. What was your career path? How did you end up in this astronomical observatory? You grew up in so what was your career path? Can you tell a little bit about your life story?
Career path.
Yeah.
Okay. No, I just happened to graduate from SVNIT Surat, SVREC at that time, and then simultaneously I got the opportunity to work at this observatory, and slowly just because I choose this one because from the other one which I got because it was nearer my home, and I thought being a new upcoming institute or the observatory, I will learn more rather than the other organization that I will be joining, which will be like normal routine work.
Okay, that's a very inspiring career that you have chosen, Dorje. There is another question on how heavy is the whole setup. How many motors drive the telescope and the dome?
I hope I got your questions correct, but then all the motors and the drives, they are specified to work at -40°C here. And as soon as it becomes dark, the telescope is exposed to the same ambient temperature as outside by opening all the domes and the windows.
Okay.
Am I there?
Yes, we can hear you. So Aditya Sharma has a question. So let me unmute him.
Hi, thanks for such a great presentation. I wanted to know that with the advent of multi-messenger astronomy, there's a lot of excitement in the community that like say there's an alert that goes after a gravitational wave detection or a neutrino detection, and then people follow it with telescopes. So is that a prospect for this telescope as well? Like,
yeah. Basically, we have this system called target of opportunity. So whenever there is any alert, if the proposal is submitted, if for the specific like supernova, etc., then the telescope is freed for that transient phenomena, whatever is happening. And also we have the other 70-centimeter robotic telescope, which also observes similarly in the robotic mode.
All right, thanks. So there's an exciting future prospect for it to have followed some event in some other messenger, like that comprises a multi-messenger event, right?
I'm sorry, I couldn't hear you properly because of the wind shift here.
No, I was just agreeing to you. That there's an exciting future prospect for this telescope that follows from multi-messenger. Yeah. Thanks.
So there are also many questions from school children. For example, how big is this telescope as compared to the Galileo's telescope? I don't know if you want to take these questions or Ramya would like to take this.
Okay, Ramya can also take it. This is in terms of very normal thing, I can say it must be around like 1,000 times or to the Galileo telescope. And Galileo, Galileo was a refracting. This is a reflecting type of telescope.
Yeah. So there is also a couple of questions. Will the Milky Way be visible now? Dorje, is the Milky Way visible now?
Yeah, I can. I cannot see any chat.
Is the Milky Way visible right now?
Milky Way will be rising at around 2 o'clock, so it won't be visible right now. So after 2 o'clock, 2 a.m., it will be visible. And right now, the moon is also closer and a little bit bright in a decreasing phase, so it won't be so beautiful as in a darker night.
Okay. So perhaps, Dorje, we could end this live session by, if you could show us one more view of the external scenery.
One more view of?
The outside, the external scenery. Yeah.
Yeah, external view. Yeah, this is the external view from the dome.
So what are we seeing? Which ranges are we seeing
Or
from
you
here?
want us to go outside and show?
Well, yeah, that would be great too.
Yeah, sure. I will just not become dark in mobile. Oh, the light put Allah.
So I see that Rajiv Nandi also has a question. So I'll unmute you. Rajiv Nandi.
Hello.
Yes, Rajiv.
Hello. Yes, sir. I want to know that it is the only telescope there or many others are there also?
Yeah, we will see that. There are a few more telescopes and we will see that probably from outside.
Okay. Another question is that what is the problem we face during data transmission at night time?
Oh, because
Yes.
they have a very, very low bandwidth internet connectivity there.
Oh, okay, sir.
For observation, we have got very good data. For internet, is our preference is more for the observational data. So those are two separate, observational as well as internet data. So internet data is less compared to the observational data. Bandwidth.
So this is the HCT that we are seeing now.
So here is the.
Is this your microwave link?
It's getting darker. You can see. No, that is the microthermal tower. Basically used for site characterization.
Oh, I see.
We have V7. This is our
Yeah, Ramya is saying it's very windy there. That's why we are hearing this noise in the microphone. So which are the other telescopes on site, Dorje?
and one or two behind our. So this is my last view from the control room. We have all the control computers. This is a flight observation going on here. This is the telescope control computer. Hello.
Hello. Yes, we can see that. Yes, thank you. What is your colleague's name?
Flight observation. HFOS GUI right now. Flight is going through HFOS.
Nice.
So we have right now chosen the R filter, and Grism is free. So other filters are free, and it's taken an exposure for 3 seconds right now because it's totally it's not dark, so only the flat uniform light is coming on the in the computer, obviously on the CCD. And there's this heater that we keep ourselves warm.
So where is the data stored? That is a question. Where do you have a server that saves?
Oh, we have this, data. There are Hanle also has a NAS server. Plus all the data are transmitted to Hosakote CREST campus in the daytime.
Okay. Okay, thank you very much, Dorje and Stanson and other colleagues for giving us this very wonderful tour of the observatory. This is a really an amazing experience for all of us. Thanks a million. Thank you very much on behalf of all of us.
Okay. Oh, thank you, Ajit, and thank you, ICTS, for giving this, providing this opportunity for all, even us, to showcase the observatory.
No, you're doing a wonderful work, and we are all very, very amazed and appreciative of the work that you do. Thank you very much to all of you.
Thank you. Thank you.
So Ramya, now
Thank
over
you.
to you. We will take more science questions.
Should we show them some of the images taken?
Yes,
from...
maybe you can start with that. If you could show, I think there are requests about the Milky Way and the images taken by the telescope. You have shown both, actually.
Yeah. So this is from normal DSLR cameras. This is how you see the Hanle sky, and in comparison to Bengaluru sky, if anyone has seen, this is already amazing. This is very godly. And this is again taken by Dorje Angchuk using his DSLR. I don't know the specifications of the camera, but we could have asked him. So this is the Milky Way band, one of the bands, what you can see. Next, this is another image, again DSLR from Rakesh Rao. He's also a movie maker, a film maker, and science. Science. He also does a lot of outreach work, science popularization work. So Rakesh Rao has taken this image when he went to Hanle, and this is again Milky Way arm, one of the arms. So this is the comet Neowise, which recently passed in the last year, and this is taken by Dorje Angchuk, and this is a very famous picture of Neowise, what he could take from DSLR again. You are seeing 2-meter HCT next to it.
I guess he won a photography award for this picture also, right? For the
I think so, yes. Yeah, it's absolutely stunning. This is the telescope in the daytime. So just to make sure, just to clear out, the observations are done in the night time, while the data transfer from Hanle to CREST campus, Hosakote, happens during the daytime. Whatever the data is collected in the night is transferred to CREST campus at Bengaluru during the morning.
Is there a reason for that, or is the bandwidth reserved for the remote control of the telescope? Is that the reason?
Yeah, that's exactly right. If you start doing the transferring during the night, then that will not support the observations. So what happens is the astronomers go to CREST campus, they sit there and move the telescope. That's what now the control is. They are taking flat images, that is the calibration frames they are taking. After taking the calibration frames, they are going to transfer the control to CREST campus. So there the astronomer sits in the CREST campus, as I mentioned to you. I think I showed the CREST campus. Yeah, so currently they are taking calibration frames at Hanle, and once the calibration frames are done, the control, the telescope control, the instrument control is given to the CREST campus, which is in Bengaluru, Hosakote, near Hosakote, Bengaluru. And the astronomers go only to the Hosakote campus, and they sit there and control the telescope. They take their images, and the images, you can see the images what you have taken via the client, the server client kind of architecture. You can see the images, and the images are stored in Hanle. While the data transfer from Hanle, the images are data transferred in the morning. So if you start transferring in the night itself, then due to the bandwidth, it will break the observations. So that is the reason that the data transfer happens in the morning.
Okay,
so
thank you.
These are some images taken from this 2-meter HCT. What you see on the left is a galaxy. which is having a lot of star formation. The star formation, it is a pseudo color image. Okay, it's not a true color. We say true color when we mix BVR kind of images, that is blue, green, and red kind of images. When we mix, we say it a true color image. But this is to see what kind of physical processes happening in the galaxy. We have mixed red and sometimes red and blue, or something in IR. So when we mix like that, we will be seeing different kind of physical processes. This is to show that there is a lot of star formation happening. New stars are being formed in the spiral arms of this particular galaxy. It is the same way here. So we mix different band images to understand what is the physical processes happening in these systems. This is again, there is a star formation happening from the spiral arms in this particular low surface brightness galaxy. So what you see here is one of the galactic star forming regions. You can see nova, recurrent nova, which is the outburst of a star and throwing out all materials. So each color will depict a different element, like a red depicts hydrogen gas, green may depict oxygen gas. So each color may depict a different element which is being thrown off. So that is what you're seeing in some of these images here. And this is again another nebula where the central star is, the core of the star remains while all the material is thrown out. This is called as the planetary nebula. This is one of the last but one stage of the star. Star has a birth and a death stage, and in between the final stage of the star, this is one of the stage of the star where it will throw out its entire material, and only the core of the star remains. So that is a planetary nebula we can observe. You can see a lot of supernovae. Suddenly there is a supernovae burst happening within the galaxy. That is what is marked in here in many of these galaxies over here. And M51, along with it, one of the supernovae which it outburst in 2011. So like this, we can have very faint galaxy observations, nebula, Crab nebula observations, newly star-forming region observations, like this is the Eagle Nebula. So a lot of the dynamic range is quite huge. We can observe a lot of objects with this telescope.
Okay, thank you, Ramya. This is wonderful. There are a lot of requests on for higher enough to show these pictures in full size, but I guess it's not possible with this setup right now. Maybe you can give a link. I'm sure that some of these images are already available on the web, right?
Yeah, in the website, I have given the website link. So if you go there and search, all these images are downloadable for
so people
purpose, for different purposes, for educational purposes, for outreach. You can download these images, and just a credit is required that this is taken from 2 meter headset. That's it.
Yeah, so feel free to check it out. There are I guess repeated questions on what is a distance reach of these telescopes. I know that it is not an easy question to answer, but do you want to give a sense of
it's not an easy question to answer. So I will try to answer it in this way, that if we want a very meaningful scientific data, so we have gone down to a redshift of say 0.05, which could I say 300 million light years away. Also, we have taken data, and we have got good data about 300 million light years. So it's again a nearby universe. We are not probing very high redshift universe. To probe high redshift universe to see what was happening 10 giga year ago, like a redshift 2 or 3, we will require very large aperture telescopes, something like 8 meter to 10 meter class telescopes. We will require. To do meaningful scientific observations, we can do a nearby universe that is like a few hundreds to 1,000 million light years is what we can go. Would that be a good enough answer?
Thank you, Ramya. So for those of you who are not familiar with this idea of redshift, it's a proxy for distance. Astronomers and cosmologists use this idea of redshift as a proxy for distance. There are some people who have raised their hand. Okay, they've lowered it. I'm missing this one. Okay, there is some requests for explaining the idea of spectroscopy. How do you spectroscopy? What is spectroscopy?
What is spectroscopy? What do you do with your cameras is just taking the images. That is, you put a filter and you take an image. So the filter is a wide band filter, which means it will take the photons from, it will collect all the photons within a band of, say, 1000 angstrom bands. But if you want to see what is happening at each wavelength, then you will need a spectrograph. So what is a spectrograph? You allow your light to pass through a prism, and this is basically in high school we have all done this. So you allow the white light to pass through a prism that splits up into multiple wavelength bands. So that is what we call as a spectrum. So now in astronomical spectroscopy, we would want to have something high resolution. So prism is kind of a diffuse. It is a very diffuse diffuser. It won't give high resolution. So in astronomy, we use. You might have heard about this. We use grating. So grating has lines carved. It's a glass plate and lines are carved through it. When the light is passing through the grating, it gets split into its respective wavelength. So the spectrum is nothing but wavelength versus number of photons in each wavelength. So that is what we call it as a spectrum. So we generally we would like to see what are the different lines in the spectrum. Each line corresponds to a chemical element. So it could be an absorption line or it could be an emission line. So each line, we try to take the total amount of photons in these lines and we compare with the lab spectrum and try to see what kind of chemical elements are present in them. So that's how we know that the universe is more majorly hydrogen and then helium. And then there are traces of all kinds of elements, but only in traces. We call them metals, starting from oxygen to all the periodic table elements.
Thank you, Ramya. This is a very, very nice explanation. There is a question about following, I guess, transient objects. So there is actually, the question is, actually space events occur for a few seconds only. I guess that is referring to the transient events. How are a formal procedure managed to make these observations quickly?
So there is a consortium, worldwide consortium, wherein a space telescope is dedicated to take the observations of the sky every night continuously, for example. So every night we have the picture of the sky. If there is something bump going in the night tonight, suddenly the telescope is able to say that, okay, there is an emission going on in this particular direction. So this could, it sends out alerts. So it sends out like a news alerts to all the observatories which have registered with them. Basically, it sends out news alerts on its website, and all the other observatories catch that news and immediately turn their telescopes towards the direction it has mentioned. So that's how we take a transient object. So as quickly as possible. The earlier we catch it, the brighter it will be, and we will get better spectrum, better signal spectrum. If we are going late, maybe because the night is not dark yet, or there could be cloudy, and after 1 hour it will clear, then we take the spectrum. It could be a little fainter, but still any kind of transients can be observed once the alert is given out.
Okay, thank you, Ramya. There are some questions on the possibility of an Indian space telescope. I don't know if you want to respond to that.
Yeah, it's still not fully on papers, but there could be something called as ExoWorld, which ISRO is planning to look at exoplanets or planets from other solar systems, basically for a planet and life hunt.
Okay, so this is apart from the existing space satellite, which is AstroSat.
Yes, yes. It is still not concrete, but there are talks going on within the astronomical community.
Right. There are some technical questions also. How frequently does the HCT require recalibration of its polar alignment?
I'm not sure about that.
Does HCT use auto guiding? Which camera is
Yes,
used?
definitely. Auto guider is used. This auto guider will look at about 2 arc-minute away from the central sky, but that is fine. So it will look for or search a very bright star in the field, and once the bright star is locked and once the target is locked, we can continue observing for hour and a half. That's possible. It's auto guiding. Is there?
Dorje, if you would like to take some questions, feel free to turn on your microphone as well. So there was a question on whether the HCT observed the nucleus of the comet Neowise.
I think Dorje Angchuk knows this better.
Sorry, we did observe new eyes, and its core was also observed, and there are many comets which was observed from HCT too. And there was a question regarding the calibration. We conduct a pointing model every month rigorously since last 20 years, and the pointing accuracy has been pretty good to 2 arc-second RMS.
I see. There is also a question maybe to Dorje more. Can the HCT see the entire horizon or some sky areas blocked by nearby hillocks?
No. We have an software as well as hardware limit. The software limit is around 15 degrees, and hardware limit, if I remember correctly, is 11 degrees. We cannot go below that because of complexity that are involved, like the mounting of the primary mirror, how they are arranged. So to avoid all those, it cannot view the horizons.
Okay. There was a question about the camera. I think you already mentioned it, but do you want to elaborate on the camera used in the HCT?
See, all this instrument that I've shown have the cameras. So as I told, HFOSC has the CCD camera of 2K by 4K, and this spec also has got its own camera, which is 1K by 1K, and I think it's around 2.5 micron pixel size. And for has, I think, if I remember correctly, it's 4K by 4K.
Okay. I think you answered, both Ramya and Dorje answered a lot of questions. And you have taken enough of your time also. Thank you very much once again on behalf of all of us for giving us this wonderful tour of this amazing observatory. Thanks again. So before I
thank
close,
you for having us.
Yeah. Thank you.
Yeah, thank you. So before we close the session, I wanted to advertise some of the upcoming events organized as part of the Cosmic Zoom exhibition. This is one of these sort of a day in the lab type program. And next week, which is on the 10th of April, 2021, 10:30 a.m., we are going to have another live session with a lab at the National Center for Biological Sciences in Bengaluru, which study how insects fly. It's a very different topic, but equally interesting, and that we encourage, we welcome all of you to attend that live session also. They use very high-speed cameras to record the insect flight and try to understand how they actually fly, which is a very difficult problem to understand. And tomorrow at 10:30 a.m. there is going to be a session primarily for children, but I'm sure all of the adults also would enjoy that. This is a book reading by Divya Panikar, where she would read her book, which is called "Have You Ever Heard a Whale Sing?" Divya Panikar is an ecologist based at the University of Washington, and she studied whales and dolphins in the west coast of India. So it's a very interesting session, and she has authored several books, and this is going to be a reading of this very interesting book for children. After which she will be speaking on some of her field experience studying dolphins and whales in the Indian Ocean. So I encourage all of you to check out the events at the cosmic-zoom.in/events, our website, and to attend the many upcoming events. And please also share this website as well as our Facebook page with your colleagues and friends and family and all kinds of networks. And we would like many visitors to attend our Cosmic Zoom exhibition. We are also opening up guided tours to this virtual exhibition, just like we have seen a guided tour in actual laboratory. This Cosmic Zoom exhibition offers a very interesting trip to the cosmos, and we have several young and dynamic people lined up to do as mediators who would provoke and encourage and question and guide you through this exhibition. So we will see the advertisement of these guided tours in the next couple of days. Please sign up, and especially school groups and various college groups and citizen groups are particularly encouraged to sign up for these guided tours. We'll have dedicated sessions for such groups. So thank you very much for joining us, and we hope to see you for all the upcoming events. Thank you very much, and a very good evening.
Thank you, everyone. Thank you, Gopi. You can end the live stream and we can cut the meeting. Good evening, everybody.